Okay, let's move over to Curiosity, the other side of the planet. So it's day 1856 since landing. It celebrated its 5th anniversary in August of this year, and it's still going strong as well. The landing site for Curiosity is Gale Crater. This is about a 160 kilometer diameter crater. There's the target ellipse that they hope to land in, and in fact they came down very close to the center of that. And the reason for choosing this crater was, first of all, it's got evidence for water having flowed into the crater as well. And then in the center of the crater is this large mound of sedimentary rock. It's about 5 kilometers tall. It's called Mount Sharp. And so this was looking at Mount Sharp shortly after landing. This is a closer view taken about 2 years ago. And they've been slowly making their way toward Mount Sharp. And right now, I think they're about at this level. So this is the overhead view from where they landed, creeping along for the last 5 years. This dark stuff is thick sand dunes, and Mount Sharp is down here. And so they've been skirting those sand dunes until they got to an area where there's a break in the dunes, and they could actually make it over toward the foothills of Mount Sharp. What they're interested in right now is this feature called Vera Rubin Ridge, and this from orbit is very high in oxidized iron, hematite. And so they've spent a fair amount of time climbing up the side of this ridge on the gentlest slope they could find. The ridge itself is about the height of a 10-story building, so that's not an insubstantial slope to get up. But since we talked last time, they are on top of the ridge now. And this is just a very busy slide showing the name of all the spots that they've stopped over the last 5 years. But right now they're down here. And this is a topographic map. This is the top of the ridge. And I think I've got a closer view showing exactly where they are right now. And so this is what the ridge looked like as they were approaching it. And so they needed to get up to the top, so they've done things like this of sort of skirting back and forth on as gentle a slope as they could find. But this obviously is geologically a very exciting area, lots of layered rocks, and then you can sort of see visually there's a distinct change from here to this stack that's on the top, and it's the top layers that they're investigating now. And this was as they approached with a higher resolution camera, seeing all of the layers. And this is what it looks like from where they were just a couple of weeks ago. I'm sorry, a week or so ago. So here's the top of the ridge right here, and so they're actually sitting on it. And one interesting thing, just looking back from where they came, is looking off into the distance. First of all, this dark stuff is those sand dunes that they were trying to avoid. They actually cut across in this area. And then you can see these dark features. Those are what were called the Murray Buttes, which they were at much earlier this year. And that's what the Murray Buttes looked like closer up. So here's one of those. Just a very geologically exciting area as well. And you can see all the dramatic layering sandstone in that particular area. So one of the things they've been struggling with since last December is the drill on board. This is the drill unit. This is the drill bit right here. And this is a percussion drill. It hammers back and forth at the same time that it's rotating, and it pulverizes a hole into the rock, and then it's got sort of an auger that pulls the sample up into the mechanism, and then it can deliver it to the chemistry and mineralogical experiments that they have on board. But the way this works is there's these fixed position standoffs. So this would of course be pointed down, but say we're drilling into a surface right here, sorry. And so using the robot arm, you position it such that these standoffs are touching the surface you want to drill. And then this whole barrel slowly moves out of the drill assembly, carrying the drill bit, and then it starts drilling into the rock. But what happened in December of last year is the mechanism that pushes the drill outward and pulls it back started giving signs of failing. And so they decided they really wanted to understand this. They've been diagnosing it for much of the time since then. And they've finally decided that they have a mechanism or a method that should allow them to resume drilling again. And so this is just a view of, sorry, I guess that is a movie. So this is a view of the drill in action a year or so ago. And so you see right here, I'm going to stop this right. Well, maybe I'll stop it. Okay, I can't stop it in the right spot. But you see there's one, two. Those are the standoffs. And then right there is the drill bit, which you can see sort of dropping out of the center. And so that's the way it should work. But what they're now trying to do, and this is on the ground, is that you will actually extend the drill so that the drill bit is touching the surface before these standoffs do. And then they will use the robot arm to push it into the rock. And the dicey part of that is the robot arm isn't just an up and down motion. It actually swings back and forth and forward and backward and up and down. And so they've been experimenting with all of the sensors on the arm to determine if they have enough sensitivity that they can tell exactly the orientation of the drill bit and then maintain that in a stable fashion. What they don't want to have happen is they get partway in drilling and then the arm shifts to the side and the drill bit gets stuck in the soil, and it's like, give me my arm back. So that's what they're verifying, but they've got they think they've got the process down, and they're still going to be investigating it for probably another month, maybe two, before they actually commit to drilling again. But drilling is very important because that's how you collect your samples, and they do have a laser spectrometer where they can zap the rocks and vaporize them, but that's not providing the same sort of information like the crystalline structure and a lot of the detailed chemistry that actually having the sample in the onboard chemistry experiments would provide. But that's good news that they're finally becoming confident that they can overcome that problem. And then the final thing on Curiosity, I just wanted to revisit this sort of a cute experiment. This was put on board by the Planetary Society, and it's both a color calibration target and a sundial. And so this is on the ground before launch, cradled in a technician's hands. This was 20 days after landing, and it's a picture from Mars, and so you can see the shadow being cast by the gnomon in the middle. And then this is what it looks like now. And so you can see how much dust has accumulated on the top of the spacecraft. But unlike Opportunity, this is powered by plutonium. And so they don't have to worry about dust collecting on solar panels. But it's just an example of, yes, the atmosphere is pretty dirty, and things do settle out. And unless the wind blows it off, then it's going to accumulate. Okay, so recapping for Curiosity, it's day 1856. They've driven about 17.5 kilometers so far, and you'll notice they've taken about twice as many images to date as what Opportunity has. So they're still going strong.